Assalamu alaikum everyone. So the topic that we are going to work today is working with indices. So previously we have learned about indices, and now we will work on how to work with these indices. Just give me a second to just set the focus on and the brightness. Okay, so we already know what indices is, or writing any number in a form of an index notation. So suppose if we write 7 into 7 into 7, so this is a repeated multiplication of the same number. So instead of writing it like this, we can write it in a form of this, 7 to the power 3. So here the 7, this is called the base, and this 3 here, which is written in the superscript, or in easy language it is written on top of 7, it is called the power. So the 7 here where the power lies is called the base, and the power and the number which is written on top of this number on top of the base is called the power. Just remember that. Okay, now the thing we are going to learn today is, what if two or more numbers which are in a form of index notation are in a state of multiplication. So multiplication in index notation. Multiplication in index notation. Okay, suppose 2 square into 2 cube, right? So if I want to multiply it, what I can do is, first of all, I can expand any index notation number to a simpler form. So 2 square basically means 2 into 2, then it is again multiplied with 2 cube, which means 2 multiplied 3 more times. So 2 into 2 into 2. Now if you look very closely, how many 2's do I have in a state of multiplication? 1 2 3 4 5. So if I want to write it in an index notation, instead of writing 5 2's, I can write it like this, 2 to the power 5, right? We have already learned this, how to do it. Instead of writing 5 2's, I can write it as an index notation. But if you look very closely, what happened here? If you look here, and what happened here, if you see that this number 2 square and 2 cube, when we multiplied, it became 2 to the power 5. So if you can realize something in here, or if you can understand any conceptual development in here, is when any index number where the base is the same and they are in a state of multiplication, their powers add themselves. I'm repeating again. If you see 2 square and 2 cube, they are in a state of multiplication, and this 2 here is called the base, and the bases are same and they are in a state of multiplication. So while a number where the base is the same and they are in a state of multiplication, we will just add up the powers. So if you see, I could have done it like this. Instead of writing it like this, I could have written it like 2. So the base 2 is common, so what we will do is, it's just taking the base 2 common here and just add up the power. So 2 to the power 2 plus 3. So now 2 to the power 2 plus 3, if I add 2 plus 3, I can get 2 to the power 5. So we can do some more examples. Suppose 3 square, 3 cube, 3 to the power 4. So what I can do is, I can expand all of it like this one, like this I have done here, and then then count how many 3's are there, and then put the power over it. But instead of doing it, which is more hassling and more time consuming, instead of doing it like this, we can see that all the base here are 3. These are similar numbers. So while the bases are same and they're in a state of multiplication, what we will do is we'll just take out the common base 3 and then we'll just add up all the powers. So here 2 plus 3 plus 4. So it becomes 2 plus 3 5, 5 plus 4 equals to 9. That is how we can do it. Okay, so this goes for multiplication. Now similar case or another way of working with indices is division. So division in index notation. Division in index notation. Suppose similar case, I have 2 to the power 7 divided by 2 to the power 5. If I want to solve it, what I can do is, instead of writing it like this, I can write it like as a fraction also. So 2 to the power 7 divided by 2 to the power 5, right? Now what I can do is I can expand it. So 2 to the power 7 means 2 multiplied 7 times. So 2, 2, 3, 4, 5, 6, 7. And then at the denominator 2 multiplied 5 times. So 1, 2, 3, 4, 5. Now we can cancel. So this 2 here goes 2, 3, 4, 5, 6, 7. So I just cancel the common 2's here with from the denominator and the numerator, taking the common factors. Now what I'm left with, 2 into 2 in the numerator. So 2 into 2, which is 2 square. If I want to write it in index notation, I can write it like this, 2 square, right? So my end result is 2 square, right? Now if I want to apply this concept here, where the base is the same and they were in a state of multiplication, it is, we just add the powers, right? But in case of division, where the base is the same, instead of adding the powers, we will just subtract it. So instead of doing it like this, we can do it in a very short way. So this can be done like this. So 2 to the power 7 divided by 2 to the power 5, we can write it like as a fraction, 2 to the power 7 divided by 2 to the power 5, right? Now if you look very closely, in both cases the base is the same. So if the base is the same and they are in a state of division, what we will do is we'll take the common base here and then we'll subtract the power of the numerator from the denominator. So 7 minus 5. So if we do it, 2 to the power 7 minus 5 gives us 2 squared. So if you see, we have got the same answer what we got by doing this long process here. So instead of doing it like this, we can do it like this, where the base is the same and they are in a state of multiplication, and we will just take the common base here and then we'll subtract the power of the numerator from the denominator. Okay, so this goes for division. Now what we studied in the last class is negative powers, right? So negative powers can be interpreted in this topic, division in index notation. What if any number gives me 3 to the power 3 divided by 3 to the power 5, right? So I want to apply this concept here. So I can first write it as a form of fraction. So 3 to the power 3 divided by 3 to the power 5. So if I see the base is the same, so I'll take the base common here and then subtract the power of the numerator from the denominator. So 3 minus 5, and as we have already studied negative numbers, so base 3 is already there, and if I subtract 3 from minus 5, I get minus 2. So this is called 3 to the power minus 2. So same thing I can do while I am dividing any two numbers of the same base, right? So 3 to the power minus 2, and if I further want to write it as a form of fraction, I can write it like 1 by 3 square or 1 by 9. So if you see, what we did is working with indices. If the numbers, if any two or more given numbers who have the same base are in a state of multiplication, we'll take the common base and then we'll just add up the powers, just as we did here. Just the opposite case in division. While two or more numbers whose base is the same and they are in a state of a division, so instead of adding the powers, we'll just divide the subtract the powers. So if it is written like this, we can transform it in a form of fraction, and then it will be easier for us to understand that what to subtract from whom. So the base is the same too, so write the base first and then subtract the numerator from the subtract the denominator from the numerator. So 7 minus 5, it gives us 2 square, and in a similar case I got this. So just try another example, mixing up this two things again. So if in a mathematical problem the bases are same and it involves multiplication and division, so multiplication plus division simultaneously, multiplication plus division in index notation. Right? So I believe you have generated some idea how to do it. Before I do it, let me just write the question first and pause the video to think about it, and then start the video for the solution. So if a problem says 2 square multiplied 2 cube multiplied 3 square multiplied 2 to the power 4 divided by 3 to the power 4 divided by 3 square divided by 2 square multiply 2 cube, right? This is a long number. What I will do is, first of all, I will just find out the numbers who have the same base. So I have got 2 here, 2 here, 2 here, another 2 and another 2, right? And now let's sort out the other numbers. So I have got 3, 3, 3. Okay, so I've got 3 3s. Now what I will do is start working with the base 2 first. So take the common base 2, write the common base 2 first. Now when there is a multiplication, right? So 2 square multiplied by 2 cube. So while they are in a state of multiplication, what I will do is I will just add up the powers. So I have 2 square multiplied by 2 cube. So what I'll do is 2 plus 3, and then I have got another 2 to the power 4, which is in a state of multiplication. So I'll just add up this power also with the previous one, plus 4, and then I have this 2 square, but this is in a state of division, right? So while this we have the same base which is in a state of division, I'll just subtract the power from the rest. So minus 2, and then again I have another 2 cube which is in a state of multiplication, so I'll just add up this power, plus 3, and then as all these numbers were in a state of multiplication, I'll just multiply 3. I'll take the common base 3 and then find out 3 square. Okay, and what is the another 3 divided by 3 to the power 4. So it means I'll just write the power 2 first, and as it is in a state of division, what I'll do is this power will be subtracted from the previous one. So 2 minus 4, and then I have got another division of 3 square. That means this power 2 is also going to be this power, I will subtract 2 from the previous power, so minus 2. Okay, and then we're done. I have no other 3's here, so let's just simplify it. So base 2 I have written here, so just add them up. So 2 plus 3 equals to 5. Okay, so if I subtract this, 4 minus 2 gives us 2. So 2 plus 3, 5. 5 plus 2, 7. 7 plus 3 equals to 10. It gives us 10, and then multiplied by, write the base first 3. So 2 minus 4 minus 6. So if we just simplify it, 2 minus 4 minus 6, if I just do this 2 first, minus 2 minus 6 gives us minus 6. So 2 minus 6, so 2 to the power 10 multiplied by 3, 2 to the power 3 to the power 2 minus 6 gives us 3 to the power minus 4. So this is the solution, 2 to the power 10 into 3 to the power minus 4. I don't need to write this as a form of fraction. I just need to simplify it in index notation. That is what we are going to do. The simple case is, if the bases are same and numbers are in a state of multiplication, we'll add up the powers, and if the bases are same and they are in a state of division, we'll just subtract the powers. That's it. Thank you for bearing with me. I hope this video will help you understand this topic. Take care everyone. Bye.